Okay, so let's try to understand these traversals in order traversal. So in order traversal means left, root, right. Okay, then we will have pre-order traversal. Pre-order traversal means root, left, right. Okay, then we'll have post-order traversal. Okay, so post-order traversal means left, right, root. Okay, now to understand this, let's take a tree. So we'll have 1, 2, 3. Okay, and just for our understanding, let's imagine like this is null, this is null. Okay, okay, so okay, so for this traversal generally we take DFS, depth first search. Okay, and so we'll be going depth wise. Okay, so while going to depth, let's take this as a subtree. Okay, so we'll be taking DFS. Okay, and let's imagine this is our subtree. So this is root, this is left, this is right. Okay, so in order traversal means left, root, right. Okay, so in this case what will be our result then? 3, 2 and right is null. Okay, so will be coming from DFS, right? Okay, so it is top down we went, right, through recursion or through DFS. Then when we will be coming back, so what will be the result for this particular subtree? It will be 3, 2. Okay, so now let's imagine this is our right node and this is left, this is root. Okay, so again left, root, right. Okay, so left is null, root is 1, right is 3, 2. Okay, so simply we will put null, we can exclude 1, 3, 2. Okay, so this is our in order traversal. Okay, so this is in order traversal. Now let's try to understand pre-order traversal. Okay, okay, again let's take the same tree, 1, 2 and 3, and let's imagine this is null, this is null. Okay, okay, so again we'll be taking DFS and we'll be going to depth wise. Okay, so we'll be going depth wise. Okay, so over here let's take this as a subtree. Okay, so this is a subtree. Now for this tree, for this subtree, this is left, this is right, this is root. Okay, and what we have said for pre-order traversal, it is root, left, right. So for this it is root is 2, left is 3 and right is null, so null we can exclude. So while coming from DFS, what will be returning? This particular DFS function with the 2 as root node will be returning 2, 3. Okay, okay, now let's imagine this is a single node, right, and this is left, this is right and this is root. Okay, okay, so over here we need to check root, left, right. Okay, so in our case, in this case, so what is root? So 1, left is null, we can exclude, right is 2, 3. So root, left, right. Okay, root 1, left is null, we can exclude, right is 2, 3. Okay, fine. Now let's try to understand post order traversal. Okay, so post order traversal is 1, 2, 3. So let's take an example, 1, 2, 3. Okay, so now over here let's again imagine like this is null, this is null. Okay, post order means left right root. Again we'll be taking DFS approach. Okay, so let's imagine like we'll be over here. So when we'll be over here, so let's say 2 will be our root node, and let's take this as a subtree. Okay, so for this subtree, what will be our left? This is left, this is root, this is right, right? So and post order traversal means left right root, right? Left 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 right root. Okay, so for this subtree, what will be our result? 3 right we can exclude, is a null node, and root. So 3 comma 2 will be the result for this particular subtree, and this will be will get while we will be backtracking from DFS. Okay, so this 3 2 we have got. Okay, and then let's imagine this as a single node. Again this will be our left, this is right, and this is root. Okay, okay, so again what we have said, like post order traversal means left right root, right? So left right root, so left is null, left is null, so you can exclude null. Then right we have 3 2, and we have root is 1. So this is the result for post order traversal. Okay, so in order means left root right. Okay, so we'll first take a result array, result equal to initialize with blank. Okay, and we'll have a DFS function. Okay, so DFS of node. Okay, so if the node equal to null, then we can simply return null. So this is just the base case. Okay, so if we are reached on a null node, then basically we can simply return null. So this is our base case. Okay, fine. Okay, then we'll go to leftwise root and right. Okay, so whenever we encounter root, we'll push the result. Okay, and whenever we encounter left or right, we'll call the DFS function. Okay, so if it has left node, right, so then we'll call the DFS function again, node dot left. Okay, and we will, for root we'll push the result dot push node dot val. Okay, and if it has a right node, if node dot right, then we'll call the DFS function node dot right. Okay, so this is done. We'll call the DFS function root, and then we'll return the result. Okay, so let's see if you have done any mistake over here. So if node equal to null, return null, DFS result dot push root right. Okay, fine, I think we are good to go. Okay, it's passing. Let's submit this. Okay, all right. So pre-order traversal means root left right. Okay, so what I will do, I'll copy paste this same code over here. Okay, so okay, I'll show you. This is just a one line change. Okay, so I have copy pasted the code. Okay, so whenever I said right, so whenever we encounter root, so we'll push into the result. So for this case, whenever we encounter root, we'll push to the result. Okay, this is done. Okay, so and let's see how we are performing. Okay, this is done. Okay, similar way, what I will do, I will push the same code into the post order traversal. Okay, so post order traversal means left right the root. Okay, so what I will do, this whenever pushing the result to result, whenever pushing the node is equal to the result, we will do push into the last. Okay, so this is also done. Okay, so we are performing Well, okay, so what will be the time complexity for these algorithms? Okay, so time complexity will be O of n, okay, and space complexity will be O of n, okay. um, I mean, this is the worst case time complexity. If we say like the average case, then it can be O of log n, but worst case we need to take worst case, right? So this is O of n. Space complexity also it is O of n. So if it is a cube tree, right, then we have to traverse to the end of the node. Okay, so this is just the space complexity for the recursion call stack. Okay, so this is for recursion call stack, right, as we are using recursion method.